Okay, in this tutorial I'm going to be teaching you how to answer this question that you've been asked, which is you need to use this weather map to compare the weather in Cardiff, which we can see here, with the weather in Newcastle, which we can see here. And this makes it a little bit harder, you've got to explain why you know there is a difference. So there's actually two parts to this question. You need to tell me what is the weather in Newcastle, what's the weather in Cardiff, compare the differences. Is it windier, less windy? Is it warmer, colder? Is it, where's the wind coming from? But once you tell me about the difference, you need to tell me why you know there is a difference. Okay, so let's just explore this a little bit further. First of all, we are looking now at this idea of weather fronts, and we can see on this map we have two weather fronts, which you should have just been reading about. Now, I'm just going to show you what this actually often looks like on modern day weather maps. What you can see here is a cold weather front there, and you can see another one here. I'm just going to put that into red just so you can see it. And you don't actually see those lines as you would on the map on the previous page. You can just see the radar here of all the rain, and that's how rain is often shown. If we move to the next page, this is a Met Office image. Here we can see our two weather fronts. That here is what we call our warm front, and we can see our cold front here. We can actually see this third one, which is called an occluded front. And an occluded front is something we don't really deal with in National 5, but just to kind of give you an idea of what it is, it's actually where this front here, the cold front, moves slightly faster than the warm front and catches up with it. It's a bit like running around a track and being caught up by the person behind you. When it catches up, when the cold front catches up with the warm front, they join to become the occluded front. And the occluded fronts, as we can see here and down here and over here and here as well, bring the worst weather. Okay, that's just a little bit extra. Let's now go back to what we're trying to deal with in this question, which is what's the difference in weather? Okay, you're being asked to answer, and you're thinking about these three things. Okay, so let's just deal with what we know without the knowledge of weather fronts. Let's just deal with this part here on wind speed and wind direction. So at various points I would suggest you maybe pause this and start putting your answer together. Okay, so let's think about Newcastle. Is the wind stronger or less strong in Cardiff? Okay, well, let's go back to what we already know. To work out wind speed, we need to think about the distance in the isobars. And we can see that in Newcastle, the isobars are closer than they are in Cardiff. And therefore, I would say that the winds in Newcastle would be expected to be stronger. And the evidence for this is that the isobars are closer together in Newcastle than they are in Cardiff. And that would be the explanation. And I'd actually use the word isobars and I'd say they're closer. On this map itself, that's probably theirs where the strongest winds are because the isobars are very close. The weakest winds are going to be found in this area down here because the isobars are quite far apart. Okay, so what else do we know just using isobars? Well, we can say something about wind direction. So what do we know about wind direction? Well, we know that in a low pressure area, which is what this is, how do I know it's a low pressure? Because I can see there's a weather front there, and weather fronts are always linked with low pressure. Okay, so I know I'm in low pressure, therefore I know that winds travel in an anti-clockwise direction. So against the way a clock would normally turn, which would be going this way. So they're going in the opposite directions. And I also know that winds follow the direction of the isobars. So the winds would be blowing along the line of these isobars. Okay, so what can I therefore tell? Well, I can tell that in Newcastle the wind is going to be coming from the southwest, whereas in Cardiff the wind is coming from the west. So that is why there's a difference. The wind direction is different in Newcastle than Cardiff, because in Newcastle it's come from the southwest, following the isobars in an anti-clockwise direction, which is what I would be saying. And in Cardiff it's coming from the west. I would even add, I'd go further in saying I know this because winds travel in an anti-clockwise direction in a low pressure area. So what have I done so far? I have talked about wind speed and wind direction, and I've given a reason for how I know there's a difference. So let's bring in the third bit, let's talk a little bit about temperature. Okay, well, what would I say about the temperature? How would I know the difference? Cardiff is sitting in this area of warm air because actually everywhere between these two weather fronts is a wedge of warm air from a warm air mass that's come from the south. Everywhere in there. Whereas everywhere outside of this wedge of warm air is cold air, which is coming from a cold air mass from the north. Okay? So, what would I say here? I would actually go and say that the temperature in Newcastle will be colder because it lies in front of the warm air mass. And what I mean in front of it is this air mass is actually moving there, but it's not yet got to Newcastle. So Newcastle currently lies in an area of cold air, surrounded by a cold air mass. Whereas Cardiff lies within the wedge, and the wedge, remember, is this area here between the cold front and the warm front, lies within the wedge, or what we sometimes call the warm sector. So it lies within the warm sector, and therefore it's going to be warmer because it's getting the warmer temperatures from that warm air mass. So that was my explanation for these three things. There is an additional thing I can actually add, and you can put this into your answer, so even though I've not asked for it here. If I was asked about rainfall, is there a difference? Well, you're going to be doing a little bit of work on this in the next few pages. A warm front brings steady rain. And temperatures tend to warm because that's the arrival of this area of warm air. A cold front tends to bring heavy rain. Okay? So, what I would say is that Newcastle is dry, but will be raining shortly when the warm front arrives. Whereas Cardiff has already experienced rain. Now you might say, how do I know it's experienced rain? Well, because this thing here, this warm front, has passed over Cardiff recently and then has moved in a west-east direction, because that's what all weather fronts do in the UK. So I'd have said a couple of hours earlier, this front that I've just been pointing out was actually back here, and it's now moved to where it is right now. Therefore, Cardiff has experienced rain recently, and there might be still some slight drizzle in Cardiff, whereas I know Newcastle is not getting any rain yet, but it will be getting it shortly. As a matter of fact, both Newcastle and Cardiff will get heavy rain when this guy arrives, but that's going to be a few hours away. Okay, so if you want to add about your knowledge about rain and how rain is affecting the two places and the difference and how you know there's a difference, and link it to this idea of warm fronts and cold fronts, then fantastic. That is an additional point you can make which will increase your marks.